Assalamu alaikum warahmatullah. In this video, I'm going to explain and to do some configuration using the ENSP. The configuration will be about implementing the scenario that we have taken in the slides. So we are going to implement this scenario. So at first we have to put two routers, and also after that we have to connect two computers. So we see at the beginning we will start a new topology. Then we are going to use these two routers and these two PCs like this. And these two actually is supposed to be close to each other to save the screen space. So I'll put them here. So for PC number 1, we use 10.1.1.1. 1.1.1. And this one is 10.1.2.1.24. Also, this router and that router, oh, sorry, we need to connect exactly similar to the example, GE001, and here GE00 to be connected to the PC, and GE00 to be connected to the PC, like this. Okay, now we need to start this topology first. And during the startup of the topology, we want to check the IP addresses of the router interfaces. So this one need to be 21.1.1 and the other one 20.1.1.2. So 21.1.1, and here we have 21.1.2. So these two interfaces must belongs to the same network. Okay, what's about this interface and this interface? These two interfaces must be belongs to the same network that includes BC2, and this interface must belongs to the same network that includes BC1. So for this reason, we are going to use the interface here. For this interface, we are going to use 10.1.2.100. And for this, we are going to use 10.1.1.100. This is only to make sure that the connectivity is there. So the first thing we have to do is to configure the IP addresses of these PCs. Exactly, for your information, we have to use 10.1.2.1, and here 255.255.255. And for the gateway, we have to use the gateway. We have to assign the 10.1.2.100, which is this interface. It would be the gateway used for this PC. Otherwise, this PC is not going to be reachable for the others. And for this PC also, we are going to use the IP address of 10.1.1.1, the subnet mask, as you can see here, 10.1.1.100 for the gateway, which is this. Okay, and here we are, finished. Then now we are going to configure router 1 and router 2. So for router 1, the first thing we undo the terminal monitor first. Then after that we go to system. We have to go to interface G000, which is the one that's connected to the PC. We have to assign an IP address 10.1.100 because we are here in router A. It's supposed to be 10.1.1, 10.100, and 24. Then after that, we go to interface number 1, and we use this IP address, which is 21.1.1 with the subnet 24. Okay, here we configured. So we already configured the interfaces. And we go here, we go to router 2 and do terminal monitor, stop monitoring. Then system, and we go to interface GE000, and we assign IP address 10.1.2.100. Oh, the 24 subnet mask. And also after this, we go to interface number 1, and we assign IP address, an IP address which is 20.1.1.2.24. So here the configuration of the IP addresses have already been done, but until now, BC1 is not going to be able to bring 10.1.2.1. So this destination is unreachable. Why unreachable? Because the what they call it here, okay, before this, let us go here and check. So let us display IP routing table. So here we can see that the 10.1, this one is router 2. 10.1.2.0, this network is already defined. 10.1.2.100, 10.1.2.255, 20.1.1.0 is already defined, which is this one. But the other network, this one, actually is not defined here for this router 2. And also this network is not defined here for the router 1. That's why we have to go to router 1 and we have to do IP root static. Then we define this path 10.1.2.0. So we tell router 1, if you want to access this network here to 10.1.2.0, in this case, you have to go through the interface 20.1.1.2, which is this. Okay, so here we are. And also at the other side, we have to define this root static as well. So we will tell router 2, if you want to access network 10.1.1.0 with the subnet mask 24, you have to use the IP address of the, what they call it, 21.1.1. 21.1.1, like that. So let us now test. So here, 10.1.1.1. It's not yet, yeah, it takes a little bit time. Then after that, it works. So now it's working. So BC2 can ping BC1, and also BC1 can ping BC2, as you can see here. But this one, because here we use this link as what they call it, private network. But what if this one has been connected through the cloud, like this? So in this case, this network here actually is going to be dashed. This network actually is going to be unsecure. This one. This one is public and unsecure. Okay. So for this reason, we have to create a tunnel or IPSec VPN connection. So exactly here, as this example that I just explained in the previous video, I'm going to show you the real configuration for the two sides, because in the slides we have taken only the configuration for one side. So for now, here we are going to see the configuration of the two sides, and we are going to test them together. So the first thing here, we are going to, after we defined the root static in router 1, then here we are going to create an ACL number 3001. So if we don't use the 3001, we can see the help here. It's a number, supposed to be a number between 2000 and 2999 for the basic access list. And for the advanced access list, it's supposed to be from 3000 to 3999. And for the specify level 2 ACL group, it's supposed to be 4000 range. So for our case now, the range must be starting from 3000. So the first ACL that we can create, it's supposed to be 3001, exactly, 3001. Okay, so we created the ACL 3001, and now we are inside the ACL view. So here we are going to create a rule. So if we write rule question mark, then we can see here integer from 0 to this big number for the ID of ACL rule. So for our case, we will start with 5. As I mentioned, never start with 1. So always keep some gap, so that slots 1, 2, 3, 4 will be empty for future configuration. If you need anything, if the requirement changes, then you can do something in that empty slots. So here in the rule number 5, if we write question mark here, we can see the options that we have. We have the deny option, we have the description, and also we have the permit. Now, the one that we want to use is the permit. Okay, after the permit, what we are going to permit? If we use question mark here, we can permit many things. We can permit, after the permit, we can use what they call it number, which is the protocol number, and also we can use GRE, and also ICMP, IGMP, IB, IB, NIB, and also OSPF, TCP, UDP. This is to decide what kind of traffic that you want to permit. So in our case, we are going to permit the IB traffic from a certain source. We can see here, we can use destination, DSCP, fragment, non-first fragment, precedence, source, time range, TOS, VPN instance. In our case, we are going to use source. So we are going to permit an IB traffic from a certain source to a certain destination. So in our case here, we are going to follow the configuration that we have in our example here. So we are going to allow the traffic from network 10.1.1.0 to network 10.1.2.0. So the source is going to be 10.1.1.0 with the wildcard 0000255, and this one is to destination, DE, destination, to destination network 10.1.2.0 with also 0000255. So here we are, we done the rule. So rule is already created. Then after we create the rule, we have to create the, what they call it, if we go here, the sketch that I draw using the paint just now together in the previous video is like this. So we create the ACL, then we assign rules inside, or we create rules inside the same ACL. Then after that, we have to create a proposal. So to create a proposal here, or before you, to create a proposal, we have to use the command. But before we create the proposal, we have to quit. We have to be on the system view. And here we have to use IPSec command, proposal. Then we write tran1, for example, as we want to follow exactly the scenario that we have taken in the previous video. So we create our proposal under the name tran1. So here we have the proposal created. So as you can see, now we are inside the proposal view. Then we have to decide what kind of security level we want to use. So here we have ESB with the question mark. It can show us authentication algorithm, and also it can show us another encryption algorithm. So in the scenario that we have in the slides, is it uses authentication algorithm, but also we can use encryption algorithm, and also we can use AH. So here, AH is must be followed by authentication algorithm only. So for AH, we can use only authentication, but for ESB, we can use authentication and encryption. But authentication under the ESB is very limited compared to the authentication provided by the AH. Okay, so let us follow the scenario. So ASB, then we select authentication algorithm. Then after that, we decide if we want to see how many algorithms do we have. So we can see that we have 3 here: MD5, SHA-1, SHA-2, 256, and SHA-2, 384, and SHA-2, 512. All of these 3 are SHA-2. So if we go to the slides here, we review back. So here, authentication in under ESB, it has MD5, SHA-1, and SHA-2. But here in this, based on the version that we have here, in our simulator, it also can implement the SM3, which is another algorithm. But for our case, we are going to use SHA-1 exactly as we have in our slides. So we enable the SHA-1. Then after that, after we created the ACL, we inside the ACL, we created a rule. Then after that, we quit. We created a proposal. We assigned an authentication protocol, authentication algorithm to be used. Then after that, we have to quit from the proposal. After the proposal, we have to create IPSec policy. So IPSec policy here, if we run the question mark, we can see that it's supposed to be followed by from 1 to 15 letters to represent the name of the policy. So here, after this, we have to write the name of the policy, P1. And after this, if we want to check also, we can hit question mark, then we can see that it can be followed by an integer number to represent the sequence number of IPSec policy. So in our case, we want to use a sequence number of 10, exactly similar to our example in the presentation slides. And after this, we have to decide which mode we want to use. So we have ISA KMP or ISA KMP, which indicates the use of IKE to establish the IPSec SA, or to use the manual to indicate the manual mode. And also we can use the CR. Please press enter to execute command. I think this is only 2 options here. But for our case here, we are going to use manual. So we decided the name of the policy and the type as well. So the name is P1 and the type is manual, and the sequence number will start with 10. So here we can see that we are inside the policy view with this name, policy manual P110. So inside the policy here, we have to decide what is the security ACL number that we want to use for this policy. So we decide security ACL 3001. So if you go here, we have created the ACL. Then inside we created rules, maybe 1 rule or 2 or multiple or 1,000, 100, it's up to you. Depends on the requirements. After we create the rules inside the ACL, then we created the proposal. After that, we created the policy. Then we link the policy with the ACL. Now we want to link the proposal with the policy. So as you can see here, after we link the policy to the ACL, now we have to link the proposal to the ACL. So the proposal name that we have created is the TRAN1. So here the proposal is also linked. After this, we want to define the tunnel local and remote parties. So we are at the router 1 here. The local party is this IP address, and the remote party is the other IP address of router 2. So here we can use the command tunnel remote. It's up to you. You can start with remote or with local, no problem. So let us start with local. So the local is 2111. So for the remote is supposed to be the 21112. Okay, so here the tunnel is already created based on this policy. Okay, so maybe we need here to also mention the what they call it, the tunnel. Definition of the tunnel. Okay. Then after that, we link this tunnel to the policy as well. Okay. So here, after we created the tunnel, don't forget, we are still using router 1. We are still configuring router 1. We have to go also to router 2, and we have to configure it as well. So after this, we have to create our SA. So we have to be in the policy. We still have to keep in the policy view. So we have to create the SA, what they call it, SPI. The first thing is outbound. So we want to use ESP, am I right? We decided the ESP protocol. So we have to use for the outbound, we link the ESP protocol that we selected in our proposal. And after that, we have to provide what they call it, a key, 54321. So exactly following the same example that we have in the slides. So this is for the inbound. For the outbound, what's about the SASPI for the inbound? It will use also ESP, but the password, it's going to be 12345. And after this, we have also to create an SA string key for the outbound ESP. So we mentioned that here we can mention symbol, and also we can use cipher. Symbol means plain text, and cipher means the key is encrypted. So following this, the example, we have to use symbol, and our password is Huawei. And also for the inbound, we are going to use okay. So here we created the password for the outbound and also for the inbound. And here we finish the configuration of our policy. Now we have to go, we have to quit from here, and we have to go to the interface that we want to involve for our, what they call it, IPSec tunnel. So here in our example, it's supposed to be gigabit Ethernet 001. So inside the interface, we have to link the IPSec policy P1. Okay, and here we said policy does not exist. So if you can go here, we can see that we created policy with the capital P, not small p. So we have to make sure that we follow the exact names that we have. So after we assign the policy to the interface, as I mentioned here, So we created the ACL. Inside the ACL, we created the rule, then we created the proposal. We decide the protocol, the algorithm that we want to use for encryption. Then after that, we go to policy. Inside the policy, we create SAs. Then after that, we create the tunnel. Then we go to the interface, network card, network interface card. Then we assign the policy. So here, after we assign the policy to the interface, then everything is finished. And now, if we try to ping this way, it's not going to receive any response. Why? Because now router 1 sends an information to router 2 that's encrypted, and router 2 doesn't know how to decrypt it. So in order to let router 2 know how to decrypt this information, we need to do the configuration also here for the router 2. So to make sure that everything here is inaccessible, as you can see, we will use the same command of ping. And as you can see, BC2 here, which is 10.1.2.1, cannot ping the PC1, which is 10.1.1.1, because the two sides does not have the same security configuration. So to do that, we have also to go to router 2, undo terminal, and after that system view. Then as you remember, we have already created the IB static root. We already created the IB static root here in this router. So if you want to check, so we can display IB routing table. So you can see here that the network 10.1.1.0 is defined, which is this, and 10.1.2.0 is already defined, which is this, and also 10.1.1.0 is already defined, which is this 10.1.1.0 this, and 10.1.2.0 is this, and 20.1.1.0 is this network. So the router already have the configuration for the needed networks. So the first thing we have to do is to create an ACL number. Also, we can use 3001. Not necessarily to use the same ACL number as we used in the router 1. So here we can use 3002. It's no problem. It can. It's up to you, because every router can use its own ACL numbers. So ACL number is not matter. It's not necessarily to be the same number. So it can be this, or also can be 3001. It's up to you. Here inside the ACL, I'm going to create a rule, also number 5. It's up to you also rule here. Number 5 or number 10 is not matter. But we have to give the permit for IP traffic source. Here the source is BC2 network, and the destination is BC1 network. It's the opposite way of the first route. So the source here must be 10.1.2.0.000.255, and the destination is supposed to be 10.1.1.0, which is the network of BC number 1. So here we are. The rule is already created. And now we have to quit from the rule, from the ACL, and we have to create the IPSec proposal. IPSec proposal, it must have a name, so maybe we use tran1 or whatever. Name also is not necessary to be the same. So after we use the tran one here, we have to decide the protocol. So in this case, we cannot change the protocol here. In order to get the connectivity, we have to use exactly the same configuration that we have in the other party. Otherwise, they cannot speak to each other. So in order to let them speak to each other, they have to speak the same language. Otherwise, they will not understand each other. If, let's say, we use different protocol or maybe different key or password, in this case, the connectivity will not be there. So that's why we have to follow the same thing. So in the other side, we use ESP authentication algorithm, and also we use SHA-1. So after this, after we created the proposal, we have to quit. Then after we quit, we have to create the ID security policy with the name. For example, P1, also the policy name is not necessary to be the same. And the sequence also, we use 10. And we mentioned that it's also manual. Then after that, we have to assign the ACL that we have created to the what they call it, to the policy. So here we use the command security ACL, then 3001. Okay. So after this, after we link the ACL to the policy, we have to link the proposal trans 1 to the policy. After that, we have to create the tunnel local IP address is 2112, and the tunnel remote IP address is 2111. So the tunnel is created and attached to the policy. Then after that, we have to create the SAs. SAs here have to be exactly the same way we created in the other side. So here, in the other side, for the what they call it, for the SASPI outbound, we used 5, 4, 3, 2, 1 for the outbound. Sorry, for the outbound in the other side, we used 5, 4, 3, 2, 1. So the outbound of router 1 is going to be inbound for the router 2. So here we will use inbound for router 2, and we will use also ESP and the password 54321, exactly as the password that we used in the outbound. So after this, we have to use the SASPI, and the outbound, we decide also the ESP protocol, and we use the inbound of the other side. So the password of the inbound of the remote side. So as you can see here, it's exactly the opposite way for the passwords, inbound and outbound. And also for the security string key, for the outbound, we will use the inbound of the symbol, because the string key in both cases, inbound and outbound, they use the same password. So here we are going to use the same password, and it's a string key inbound ESP symbol Huawei. Okay, now we finished the creation of the policy. After this, we have to go to the interface, Gigabit Ethernet 001, And here we have to assign the IP security policy P1 to the interface. And after this, we can quit. So here, after we configure the two sides in a good manner, so every side can understand the other side. So we can see here that now we're supposed to be able to ping. Okay, now we can see the ping and its response. So this is from BC2 to BC1 and also from BC1 to BC2. So here we are, and that's all about the IP security and its configuration. So I hope everybody can understand, and also I'm welcoming any question. So if you have anything not clear, or you want to understand anything, or you want me to clarify anything, you just WhatsApp me or contact me through the email, and I'm going to do my best to help you, inshallah. So please guys, give it enough time to do practice and see how to be ready for the final exam. Good luck for you all, and see you inshallah in the next video.